Because they're the same measurement on the hypotenuse and the base.
Ooh. I'm actually glad that you said that, because that's not correct. Do we know for a fact that this is a 90 degree or right angle or right triangle? No. Okay. Reynold, unless it tells us this is 90 degrees, we cannot assume anything. Okay. So don't assume that it's HL. Remember, HL, you can only use it if you have right triangles. Neither of these are right triangles that we know of. Okay. So which theorem should we use if we're not using HL? Side, side, side. So we've got this side corresponds to this side, right? This side corresponds to this side. How do we know that the third sides are equal?
Because they both share it.
Very good. Aren't they the same side? Okay. When a side is shared by both triangles, you can automatically assume it's also congruent. Okay. So what I do just to help me out is I draw like a third marking, just so I know, okay, that's the third side and they're equal to each other because they share it. Okay. If you want to write a little note, shared sides are always congruent. Okay, so if a triangle ever shares the entire side with another triangle, those are always congruent. So then these triangles are congruent by the SSS theorem. Awesome. Reynold, I'm going to give you a chance on number 2. Are those two triangles congruent?
No.
No. Very good. Why not?
Because they're not the same size.
I mean, you're not wrong, right? They are not the same size. But let's think about, they're right triangles, right? So we automatically know we're probably going to apply the HL congruence theorem, okay? We're going to try to apply HL. Now, what do we know the hypotenuse in the first triangle, in this one that I just boxed in?
No.
No. So automatically, we know that they're not congruent because we need to know something about this hypotenuse, right? Because we know something about the other hypotenuse, right? So if the hypotenuse of one is not equivalent to the hypotenuse of the other, therefore these are not congruent. The HL theorem cannot be applied. Okay? Because the hypotenuse of the second one is congruent to the leg of the other one. So there's no way these can be congruent. Questions on number 2. This one was kind of tricky to see. Okay? But just recognize number 2, or the first triangle, we don't know anything about the hypotenuse. But the second one, it tells us that the hypotenuse is congruent to one of the legs of the other one. And that's not how we apply the theorem. All right, guys, number 3. What do you guys think? Congruent or not congruent? Samantha, very nice. Samantha says congruent. Why do you say congruent?
Because there's two right angles and the legs are the same.
Ah, 2 right angles. Very good. So we know we're applying which theorem? HL. Very good. So, and you just said legs are congruent, right? But are the hypotenuses congruent? Which of these sides is the hypotenuse? The middle.
Shared.
The one, yes, the shared one in the middle. Very good. So if they both share it, right, then this hypotenuse must be equal to this hypotenuse. We have sufficient information to say that we can apply the HL theorem. Because we have a hypotenuse that's congruent to another hypotenuse and two legs that are congruent. Okay, good. Questions on number 3, guys? Okay, let's take a little pause. Let's switch over from the... So 5.6, guys, is all about proving congruent triangles, but using 2 new methods, okay? These are the last 2 methods, and there's a slide in this, on these notes, that's super important because it basically gives you all of the congruence theorems that we've learned, and it puts them all into one slide, okay? It's great for studying. Okay, so ASA is angle, side, angle, and AAS is angle, angle, side, okay? ASA congruence postulate. If 2 angles and the included side of one triangle are congruent to 2 angles and the included side of a second triangle, then the 2 triangles are congruent, okay?
Can you please reset your attention?
Sure. Okay, guys, so one key here, guys. And if we look at ASA, right, the name of this congruent postulate, angle, side, angle. The side is sandwiched between the 2 angles, right? That's exactly what's required when we're looking at our triangle, okay? So if we're given a side or an angle D, right? That's an angle, the side, and then the angle F, okay? That's what's required to apply angle, side, angle, okay? As long as the side is sandwiched between the 2 angles, you can apply ASA. So how I remember it, guys, is I always correlate like the order. So like, for example, side, side, angle. I'm sorry, side, angle, side. Do you remember that was the very first one that we learned? How the angle had to be between the 2 sides. That's how I always look at it. So it has to be an angle, a side in between them, and then lastly, another angle on the other side, okay? And we call that side that's in between the 2 angles the included side. Okay? There's also the angle side congruence theorem. So if 2 angles and a non-included side of one triangle are congruent to 2 angles and the corresponding non-included side of a second triangle, then the triangles are congruent. So if G is congruent to K, J is congruent to M, and JH is congruent to LM, then the 2 triangles are congruent. And we can apply that same logic here, guys. AAS is angle, angle, side. So if we look at what we're given an angle, and a side. See how the side is not in between the 2 angles? An angle, a side, and an angle. Angle, angle, side. So one thing I want you guys to notice, if you're ever given two angles and a side, doesn't matter which one. They're always going to be congruent triangles, okay? Now, the reason that is because we can either apply AAS or ASA to any of those combinations, right? So if you're ever given, let's write that down. If you are given two angles and a side, the triangles will always be congruent. Okay, but what differs is why they're congruent. So you have to make sure that you're paying attention to which congruence theorem you're applying. If the side is in between the two angles, then it's ASA. If the side is outside the two angles, it's not the included side, then it's AAS, angle side. What's that? Yeah, I won't change. I'll give you guys another second to copy this down. Say it again.
It keeps on pausing for some reason.
Yours?
Yeah, like I tried writing something, it just stopped.
Did your notability update?
Uh-huh.
Okay,
No, it was trying to update, I was in the middle of a class.
So you canceled it?
Yeah.
I might have done it last night on its own, to be honest. Is anyone else on Zoom having troubles with notability?
Mine is glitching a
Yeah,
lot.
I'm having troubles.
Yeah.
Just that one I told you.
Yeah, when you're submitting it, Ella? I
What
think
did you say?
when you're submitting it, right? It was that issue?
Yeah,
Okay.
submitting it.
When, I don't know, like I was, what class was I? I think it was GH. Like everyone's notability went down all at the same time. Okay. Summary. This is the page if you want to star it, highlight it, make sure you know where this slide is when you're studying. These are all of the postulates and theorems we've learned so far to prove that triangles are congruent. This is everything you need to know for your test, except for 4.1. Remember what 4.1 was? Where it was like all the angles inside of a triangle are 180, and then the exterior angle is the other two angles that are not the one next to it added together. Other than 4.1, these are all the theorems and postulates that we've learned. This is a super important slide for you guys, okay? SSS, SAS, HL, ASA, and AAS. So we've got 5 of them. Okay. Theorems that we can use. If we have two sides and an angle, the only one that we can use is if the angle is in between the two sides. So guys, we don't have enough. Yes, two angles and a side is one of our theorems. We can apply that. Example 1. So we're given angle X is congruent to angle V, okay? So I'm just gonna go ahead. We have to prove that these two triangles are congruent. I'm just gonna go ahead and fill in my diagram what's given to me in the problem, okay? So X is congruent to V. And it says that the angle YZW, let me highlight it so we can see it, Y to Z to W, that's this one right here. Oops. Is congruent with YWZ. So I'm going to highlight the other one, Y to W to Z. So that would be this one. And we also know that XY, which is this line segment, is congruent to VY, which is this one. It wants us to prove that XYZ that will be the green triangle, XYZ, is congruent to VYW. The blue one. Well, we have an angle and a side in both of those triangles. Does anyone know? All we need now is another angle. Doesn't matter which angle. How could we figure out that two of these angles are congruent inside of the green triangle compared to the blue one? Do we know anything about this angle right here? About angle X, Z, Y. Do we know anything about that angle? What'd you say, Reynold?
I was gonna say something about the hypotenuse, but
Remember, we don't know that these are right angles, right? It doesn't tell us anything about right angles or right triangles. Do we know anything about the triangle in the middle? Let's look at it a different way. Do we know anything about the triangle YZW? Marcos, what do we know?
Its base angles are congruent.
Ah, its base angles are congruent. So what kind of triangle does it have to be?
Equiangular.
Not equiangular.
Equilateral.
Nope, not equilateral. Isosceles. Remember, when the two base angles are congruent, it could be equilateral or equiangular, but we don't know that for sure. What we do know is that those two legs have to be congruent. So we know that this YZ must be congruent to YW. Why do we know that?
Because they share a side.
Very good. They share a side. Okay. So was side angle, is that one of our right now? Okay. What we need to do is figure out, can we put this angle, can we do anything, can we figure out this angle in any way, shape, or form? Can we relate it to any of the angles that were given to us? Marcos, what do you think?
The one across from the one from the other triangle.
Ah, YZW, right?
YZW.
Okay, how is it related to YZW?
It's adjacent.
It's adjacent, and together they form what?
Y.
Together, no. Like, let's say we took, when I say together, this is what I mean. Let's start at this angle, and let's finish this angle, and then continue all the way through the other one. What do we have, guys? A straight line, 180 degrees, okay? So, that angle, right? Oops. Let me erase this. So, XZY plus YZW, angle YZW, equals 180 degrees. Okay? Adding the green angle with the red one will give us 180 degrees. Let's do the same thing with YWV. YWV plus what angle will give us 180 degrees? Which angle will form the linear pair?
YWZ.
Good, YWZ. Excellent. Do we know anything about YW or YZW and YWZ? Look at what's given.
Can you repeat what you asked, please?
Do we know anything about this angle and this angle? YZW and YWZ?
They're congruent.
Ah, they're congruent, right? Because it tells us that in the beginning. Okay? So if they're congruent, we can just substitute one for the other. So let's take YWZ and let's substitute YZW. So we're going to get angle XZ, I'm sorry, not XZ. Angle YWV plus angle YZW equals 180 degrees. So we've got this equation, and we've also got this equation. Does anyone see anything interesting? Looking at just those two equations, do you guys see anything interesting? Angle XZY, if we subtracted YZW from both sides, we would get XZY equals 180 minus angle YZW. If we did the same thing to the second equation, angle YWV equals 180 minus angle YZW. Do you guys see anything interesting about these two equations? Well, if they're equal to the same thing, guys, we can just set them equal to each other. So we can conclude that angle XZY is equal to angle YWV. If we know that these angles are congruent, right? So the ones that I put in green, we now have an angle, and a side. An angle, and a side. Was AAS one of our theorems? Okay, so angle, side gets applied, and we can prove congruence. Yeah. Okay, let's try another one. Okay, so we are given that JL, which is this line segment right here, it bisects the angle KLM. Okay? Now, let's go ahead in our diagram. What does that tell us? Like, what can we start filling in our diagram? If JL bisects KLM, what can we put in our diagram to represent that? To help us figure out this answer? Well, what happens when something bisects an angle? When a line segment bisects an angle, what does that mean? Did we forget? Bisects.
It goes in the middle.
Yeah, it's right down the middle, right? So it divides it into two equal parts, okay? So what can we say about KLJ and JLM, those two angles? KLJ and JLM. If the blue angle is bisected by the red line segment, what can we say about KLJ and JLM?
They're supplementary?
No. You're on the right track though, Karen. They're congruent, okay? KLJ must be congruent to JLM. Why? Because that line segment bisects the angle. Whenever it says bisects, it divides it into two equal parts, right? It's basically the midpoint of the angle. So now we have two equivalent angles next to each other, okay? It also tells us that angle K and angle M are congruent. That's already filled in for us. Do you guys see that?
Yeah.
And then lastly, it wants us to prove that the triangle on the top is congruent to the triangle on the bottom. JKL and JML.
They share a side.
They share a side. Marco's pointed out they share a side. Which side do they share? This one in the middle. So what do we have?
Side angle side.
We don't have side angle side. What do we have, guys? This is an angle, right?
Angle.
Angle,
Side.
side. Angle, side. Is AAS something we can apply? Yes. This is a theorem that we just learned, so therefore they are congruent. Questions? Okay, we're going to do one more example. Identify the postulate or theorem that proves the triangles are congruent. Okay? Keep in mind there could be more than one answer for these. All right? So for number 1, I always will start filling in my diagram with information that I know. Okay? So if this angle is 15 degrees, I'm just going to put a one angle mark. And I know that this angle on the bottom is 15, so I'm going to put another one. Okay? Because those two are congruent, right? I'm going to put 2 around the 150 and 2 around this 150. You guys, can we apply a theorem that we've learned to prove that these are congruent? Well, let's look. We've got an angle with an angle, a shared side, so 2 sides are congruent,
Angle, side, angle.
and an angle and an angle. Angle, side, angle can be applied. Do you see how much easier this is when we just start filling in information in our diagram? The very first thing that you guys should do is fill in information in your diagram. Okay. Number 2, 90 degrees and 90 degrees. I'm just going to put 2 90-degree marks just so I'm aware. When it's 90 degrees, what theorem should we try to apply?
Hypotenuse leg theorem.
Okay, hypotenuse leg theorem, good. Can we apply that here?
Yeah.
Yes. Why?
Both are 90-degree angles, and the hypotenuses are both equal.
Mm-hmm. Do we have a leg that's the same?
Yeah.
And 2 legs that are the same. So we can apply the HL theorem. This one's actually kind of cool. What other theorem could we apply to number 2? Does anyone see it?
Is it SAS?
Ooh, yes. Side angle side. How? Here's our angle.
Because the 2 angles, there's 2 angles and there's 1 equivalent. Wait, no, there's 1 angle and then 2 same sides. You know what I mean?
Yeah, I know what you mean. But what is the side that's not told to us that it's congruent, but we can figure out that it is congruent, Nilisha?
The one in the middle.
Good. The one in the middle,
Shared
right?
side.
Because it's a shared side. So side, angle, side. So SAS could also be applied. Guys, there's one more. Does anyone see it?
Side, side, side.
Yes, Teresa, very nice. Side, side, side. Don't we know that all 3 of those sides are congruent? Therefore, we can apply the side, side, side. Okay? Doesn't matter which one you guys use. Some of these, there's going to be more than one that you can use. Samantha, I'll go back at the end, okay? Some of these, there's more than one that you could use. In this example, you could use any of those 3. You could have used HL theorem, SAS, or SSS. Number 3. What do you guys think? Well, we don't know any of the angles inside. So what should we try to apply first? If we don't know any of the angles inside, we know an angle on the outside, but let's say we forgot that about vertical angles, the definition of vertical angles. What could we apply without using any angles?
Side, side, side.
Good, side, side, side. Do we have 3 congruent sides?
Yeah.
Yes. We have a side here that matches up with this one. This one's a shared side, and then these bottom two sides match up. So side, side, side could be applied. What else could be applied, guys? Now let's start looking at the angles. Do we know any of the angles?
Hypotenuse, right?
Karen, don't get confused. Do we know that this is a right triangle? We don't.
No.
It looks like a right triangle though, Karen. I will agree with you. But remember, do not assume it's a right triangle unless it tells you. Right, Marcos?
Yeah.
Okay? So, but we do know these two angles. How do those help us? Can they help us?
They're equal to one another, so if you use the vertical angle theorem.
Vertical angles. So this one must also be equal to that one, which is also equal to that one. So if we know this angle, what other theorem can we apply? Side angle side. Beautiful. Now, we only know that one angle, so that's where it ends, okay? But these two can also be applied to this one. All right, guys. Example 4. Go ahead and put on the top. We're skipping this one. And we have about 4 minutes, between 3 and 4 minutes. Please turn this in and get started on your homework, okay? Ask any questions while you guys are starting your homework. Let me know what we're still confused on. Okay? But go ahead, Teresa.
Was the quiz that we took, I think it was a few days ago, is it open to like review? Because I checked it yesterday and it wasn't open.
I didn't do that. Let me do that now. I'll do that while we're still on the Zoom call.
Thank you.
Yeah.
Mr. Yurko,
Yes.
my notability started lagging and messing
Okay.
up again, so it just keeps on kicking me out.
Oh, that's no problem. Do you need me to go back to any of the slides? Samantha, which slide did you need me to go back to?
Can you go back to example 1, please?
Yeah.